Good morning, children. Today, let us discuss some questions of bijective functions. So, let us discuss the question. Here we have to check some examples. We have to check whether the given function is a bijective or surjective injective, and whether it is a bijective or not. So, here the function is defined from R0 to R0, where R0 is the set of all non-zero real numbers, and the function f of x is equals to 1 by x, reciprocal function. Okay, so here let us check whether it is injective, surjective and bijective or not. Okay, it is defined on the set R0, that is set of all non-zero real numbers. That is, in this set, the domain, in the domain there are all real numbers are there excluding 0. 0 is not there. Okay, now for every number there will be a reciprocal in the codomain. So we can relate, suppose the number 1 by 7 in R0 in the domain set. If we consider this number 1 by 7, its reciprocal is 7, so we can relate this with 7. So this 7 has the pre-image in the set, domain set. Okay, if we consider the element 2, its reciprocal is 1 by 2. We can relate this 2 with 1 by 2. Image of 2 is 1 by 2. Then image of 3 by 4 is 4 by 3. So every element in the set R0, that is codomain, has pre-image in the domain set. That is, range and codomain are equal, and as you can see here, it is a 1-1 function, and it is onto function also, because all the elements in this codomain have pre-image in the domain set. So it is injective as well as surjective, and hence it is a bijective function. So R0, or this function f, which is defined from R0 to R0, is a bijective function. That is, it is 1-1 as well as onto. So it is 1-1 onto function. Now here we have to check, if we replace this domain by the set of natural number n, then will it be a bijective function? Will it be 1-1 onto? So here, if we replace this domain by n means set of natural number, the numbers will be 1, 2, 3, 4, and their reciprocals, they are here in the set R0. So reciprocal of 1, reciprocal of 2, 1 by 2 we can relate. So it is 1-1, no doubt. It is a 1-1 function, but it will not be onto functions, because the numbers which are 1 by 2, 1 by 3, 1 by 4, 1 by 5, they will have the pre-image in the domain set. Means they are related to the numbers in the domain set. But then other than that, these numbers, means the whole numbers, the negative numbers, they will not have any pre-image in the set n. Hence, it will not be onto function. Okay, so this will not be onto if we replace the domain by n. Now in the second question, the function is defined from n to n. That is, set of natural number to set of natural number. Means domain is set of natural number, codomain is also the set of natural number. And the function f of x is x square, square function. So f of x is x square. Now observe this element in the set n. 1 square will be 1. So we can relate this 1 to 1. We can draw this arrow diagram like this. 2 will be related to 4. because it is a square function, 3 will be related to 9. Okay, 3 is related to 9. What about the remaining numbers in the codomain? So as you can see here, 2 is left. The image 2 does not have any pre-image in the domain set. 3 does not have any pre-image in the domain set. 5 does not have any pre-image in the domain set. As you can see, it is a 1-1 function. It is 1-1, but it is not onto, it will be into function. This is an into function because the range is 1, 4, 9, 16, so on, and the codomain is the set of natural number. They are not equal. So range is not equal to codomain, hence it is not onto function. This is into function. Okay, so by drawing the Venn diagrams, by drawing the arrow diagrams, you can check. It is very easy to understand whether the function, it is very easy to check whether the function is 1-1 onto or not. Or theoretically also you can prove. Let us assume that x1 and x2 will consider two elements in the set n. This is domain set. x1, x2 belongs to n. F of x1 is equals to f of x2. Now f of x1 is x1 square because the function f of x is x square. So x1, f of x1 will be x1 square, f of x2 is x2 square. Shift this x2 square to the left hand side, x1 square minus x2 square equal to 0. Expand the bracket using the formula of a square minus b square, it is x1 plus x2 equal to 0 and x1 minus x2 equal to 0. From this we get two values, x1 is equals to minus x2 and x1 equal to x2, but this will not be possible as x belongs to the set of natural number and hence there is no negative number and hence we get only x1 equal to x2. So x1 equal to x2, it means that f1 is 1-1 function. So when we consider f of x1 is equals to f of x2 and if we get x1 equal to x2, then we can say that the function is 1-1 function. If we get another value, more than one value of x1 and x2 relation, then it will not be 1-1 function. And onto range of f is 1 square, 2 square, 3 square, that is 1, 4, 9. This is not equal to n. This is not equal to the codomain. And hence range is not equal to codomain, hence it is not onto function. So in this way we can prove theoretically also. Then in the third question, the function f is defined on R, set of real numbers to set of real number. Domain is R, set of real numbers. Codomain is also R, set of real numbers. Function f of x is x square. Okay, now consider the domain elements. 0 is related to 0. 1 square is 1. So we can relate 1 to 1. And minus 1 square is also 1. Minus 1 square is also 1. We can relate minus 1 to 1. So this element has more than one pre-images in this set R, that is in the domain set. Then this 3 we can relate to 9 and minus 3 also we can relate to 9. Now which type of function it is? It is a many one function. So this function is many one function. It is not 1-1. This function is not 1-1 function. Okay, so theoretically also we can prove. Consider x1, x2 belonging to R. F of x1 is not equal to f of x2. x1 square is equals to x2 square. Same terms here, x1 plus x2 into x1 minus x2 equal to 0. Equate each bracket with 0, we get x1 equal to minus x2 and x1 equal to x2. Here we are getting two values, therefore the function f is not 1-1 function. So f is not 1-1 function and we'll check whether it is onto or not. Observe this set R carefully. In this set R, if you see the negative numbers, because it is the set of real numbers, so there will be negative numbers also. So all the negative numbers, they will not have any pre-image in the set R, because we know that square root of negative numbers is not real. Therefore, we don't get the pre-images for the negative numbers. Hence, this range is not equal to codomain, because in the range all positive numbers including 0 are there, and in codomain negative as well as positive numbers including 0. Therefore, we can say that range of f is not equal to the set of real numbers R, hence f is not onto also. So this function is, when it is defined from R to R, f of x equal to x square is not 1 1, neither 1 1 nor onto function. One more example we are going to discuss. This function f is defined from R to R, where f of x is greatest integer function x. This is read as greatest integer function x. Now f of x is greatest integer function. Children, see what is a greatest integer function and how to consider its value. When we write greatest integer function 3.5, we have to consider whatever the number is here, we have to consider the integer part of this number. So 3.5, its integer part is 3. 3.0009, its integer part is 3. So greatest integer function is 3.5. Greatest integer function 3.5 is 3. 3.009 is 3. 3.99999 is also 3. Okay. So when we consider these numbers from the domain, 3.5 will be related to 3. 3.009 will be related to 3, and 3.999 also. So whatever the numbers which are coming from, which lies between 3 to 4, there are many numbers, infinite numbers between 3 to 4, they all will be related to 3 only. So tell me which type of function it is. Yes, this is a many one function. It is many one function. Therefore, it is not 1 1 function. It is not injective function. Therefore, here the function is not injective. It is not 1 1 function. And when you observe this R, that is codomain, carefully, there are integers also, fractions also, and negative numbers also. So integers and fraction, they do not have any pre-image in the set R, and hence it is neither 1 1 nor onto, neither injective nor surjective, hence it is not a bijective function. It is neither 1 1 nor onto function. So children, in this way we can check whether the function is injective, surjective and bijective or not.